Condensing logarithmic expressions is one of the most important things that you can learn regarding logarithmic functions. That's why I wanted to compile my best examples of teaching inside of the classroom, step by step, of how to condense a logarithmic expression. We're going to use the rules of logarithms to go ahead and condense simple expressions, as well as ones that are more advanced, dealing with fractions and multiple uses of parentheses. Everything is inside of this video, and I hope you enjoy. Welcome. All right, so when we're condensing, the whole goal of condensing is what we're going to do is we're going to rewrite our logarithms as one single logarithm. So we go back to our properties of logs, which I have right here, and I understand that if I have the addition of two logarithms with the same base, I can rewrite that as the product of what we're evaluating for if the logarithms of the same base. So notice we have two natural logarithms, but remember with the natural logarithm, our base is going to be e. So therefore, since we have two logarithms with the natural base e and we're adding them, I can simply just rewrite this.
Ms. Morrison, please call the main office. Ms. Morrison, please call the main office.
Of ln of 3x, which is the product of 3 times x. Thanks. Here we go. So what I have here is log base 4 of 7. I don't know why I did that. Log base 4 of 7 minus log base 4 of 10. And again, by applying our properties of logarithms, what the properties of logarithms say is if we have two logarithms with the same base and we're subtracting both quantities, we can rewrite that as one single logarithm as the quotient of our values. So therefore, I can rewrite this now as one single logarithm of log base 4. It has to be the same base. That's a mosquito. Log base 4 of 7 divided by 10. Okay? So there you go, ladies and gentlemen. That's how you use the properties of logarithms to go ahead and condense a logarithmic expression into one single logarithmic expression. Thanks. So in the last couple examples, what we looked at, Diamond, was always taking that power and bringing them in front. So now the first thing we're going to do is we're going to put that up there. So I have ln of 5 squared minus ln of 3. Now obviously, ladies and gentlemen, we can simplify 5 squared. I can see that. So that becomes ln of 25 minus ln of 3. Now, how do you go from subtraction of two logarithms to one single logarithm? You have to use the quotient. So therefore, my final answer is ln of 25 over 3. And you don't need to write base e, again, as we talked about. That is assumed. The first thing you're going to want to do is undo using the power rule, which is basically going to take our terms in front that's being multiplied and raise them as the powers. So that's going to be log of x squared plus log of y cubed. Now, you guys can see I can now condense this using the power rule, the product rule. When I have two logarithms with the same base, which is 10, I can rewrite them as the product. So I can rewrite this as one logarithm of log of x squared y cubed. So, ladies and gentlemen, this is a problem. What I have is 6 ln of x plus 4 ln of y. What we want to do is condense this down to one single logarithm. So to do that, the first property we're going to apply is our power property, which if we're multiplying a number by a logarithm, we can raise that as our power. So therefore, I'm going to rewrite this as ln of x to the 6th plus ln y to the 4th. Now that I have it in this case, we understand that if I'm taking two logarithms with the same base, since these are natural logarithms, they have the base e, I can rewrite this as one single logarithm as not just the addition of two, but one single as the product. So therefore, I can rewrite this as ln of x to the 6th times y to the 4th. So there you go, ladies and gentlemen. That is how you condense your logarithms to one single quantity. Thanks. Here's another one that a lot of students, kind of get to. They understand sometimes the addition and the product. And so forth. But when I have 1/5 log base 3 of x, all right, remember that we can take whatever we're multiplying our logarithm by and raise it to the power inside of our logarithm. So therefore, I have log base 3 of x raised to the 1/5 power. Now, the other thing I want you to remember is if I have x over a over b, that's going to equal the b root of x to the a. Therefore, I can rewrite this, and this is how I'm going to have my students rewrite it, as the 5th root of x to the 1st power, which would just be x. But when I'm writing mine as a single logarithmic quantity, I want to rewrite it back there as a root rather than having the rational exponent. Thanks. OK, so in this case, I have 2 log base 2 of x plus 3. Now, this one gets a little students because it's a lot simpler than it's going to look. But this one mixes up with a lot of students because they understand, OK, I take the 2, I can raise it up top. So therefore, I have log base 2 of x plus 3 squared. But then they say, well, there's something I have to do with the addition, right? I remember when I was expanding, or condensing, I could have the addition of 2 different logarithms I could rewrite as the product. Well, ladies and gentlemen, again, this isn't the addition of 2 different logarithms. This is the addition of x and 3. So we can't rewrite that as 3x, right? You obviously understand that 2 plus 3 is not equal to 2 times 3. That's true when we have logarithms, when I'm taking the log of x plus the log of 3. However, when we're just dealing with our numbers, we're not going to be able to rewrite this. So this is going to be our final condensed form. Thanks. OK, so in this problem, what I have is -4 log base of 8, log base of 8 raised to 2x plus log base 8 of x plus 1. Now, again, if we were just going to look at simple numbers, if I had -4 plus 5, I could rewrite that as 5 plus a -4. Right? Or really just rewrite that as just 5 minus 4. And when applying our properties, that might be something that might make this problem a little bit simpler. So what I'll do is I'll rewrite this as log base 8 of x plus 1 minus 4 log base 8 of 2x. Now, either way, I can see now, all right, I can take my 4, raise it up top. So now I have log base 8 of x plus 1 minus log base 8 of 2x raised to the 4th. Now I have the difference of 2 logarithms with the same base. I can rewrite now as the quotient in one single logarithm. So therefore, it's going to be x plus 1 divided by, now I can rewrite 2x raised to the 4th is going to be 16x to the 4th. So there you go, ladies and gentlemen. That is how you simplify your logarithm to one single quantity. Thanks. So, ladies and gentlemen, in this example, again, as I mentioned, the first thing we want to do is we want to take our powers, use the power rule in front. So anytime, Emilio, that we have terms in front, we want to rewrite those as the powers. So therefore, I'll write this as log base 3 of x plus log base 3 of x squared plus log base 3 of x cubed. Now, I have 3 logarithms. And to rewrite 3 logarithms as one logarithm, I'm going to have to use the product rule. So I'll rewrite this as log base 3 of x times x squared times x cubed. Therefore, then I have to use the power rule. The product rule of exponents. So x times x squared times x cubed is going to be, I add all the powers, which gives me log base 3 of x to the 6th. And that is your final answer. All right, so now we have multiple products. And so far, we talked about, well, if I have the addition of one logarithm plus the addition of the logarithm with the same base, I could rewrite that as the product. But what is that? Does that still hold true when I have 3 of them? And the answer is yes, of course. The first thing we do, though, is we can take each one of these numbers up in front. Now, a lot of times, when we're dealing with condensing, what we're dealing with is, expressions that really can't be simplified. But here, I have 1/2 squared, so I can rewrite that as ln to the 1/4. Okay, now, since we have the addition of all these natural logarithms, which all have the same base, I can rewrite this as the product. So therefore, that's going to be ln of 40 times 1/4 times x. Well, obviously, I can simplify this further. 40 times 1/4 is just going to be 10. So I have ln of 10x is going to be my final simplified expression. Thanks. Main important thing, guys, is I see a number in front. Whenever you see a number in front and you're trying to condense, then we know that we can rewrite that as log base 3 of x plus log base 3 of x squared, right? You take the 2 and you bring it up top, minus log base 3 of 27. Now, there's a couple things that we can go ahead and do with this, all right? The next thing is you guys see that we have 2 logarithms that are separated by addition. When we have 2 logarithms that are separated by addition, we can rewrite them as the product using one logarithm. So that would be log base 3 of x times x squared minus log base 3 of 27. Now, ladies and gentlemen, if you have x times x squared, going back to the rules of exponent, that equals what? X cubed. So you could have log base 3 of x cubed minus log base 3 of 27. Now, there's two different ways that I'd like you guys to understand how we could rewrite this final answer. You now see that you have the division, right? Or I'm sorry, subtraction. So you could use the division property, which would be log base 3 of x cubed over 27. Which would look like this.
Don't erase it.
I'm not. Or you can also see that, ladies and gentlemen, can we evaluate, whenever you have a logarithm and you see it's just numbers, always look to as far as evaluate. Can we take 3 raised to a number and get 27? 3. So you could also just rewrite this as log base 3 of x cubed minus 3. You can also just evaluate it. And then once it's subtracting, then we can't use the rules of exponents. We can't use those. OK, welcome. So what I have here is I have 3 log base 3 of x plus 4 log base 3 of y minus 4 log base 3 of z. Now, in an applying problem like this, the first thing we always want to do is, again, bring up our exponents. And we have a couple of them, right? So we have log base 3 of x plus log base 3 of y to the 4th. That's x cubed minus log base 3 of z to the 4th power. All right? Now, the next thing I'm going to do is I'm just going to work from left to right, kind of like following the order of operations, work from left to right, and apply my properties. So here I have the sum of 2 logarithms with the same base, so I can rewrite that as the product in one logarithm. So that's going to be x cubed y to the 4th minus log base 3 of z to the 4th. Now, again, I have the subtraction, so I'm going to want to rewrite this now as the quotient of one single logarithm. So I have log base 3 of x cubed y to the 4th, all divided by z to the 4th. So there you go, ladies and gentlemen. That is how you condense a logarithm with multiple terms into one single quantity. Thanks.
Ms. Rosa, can you please come to the main office?
All right. To do this problem, what we're going to work on is condensing. If you guys can remember, when you're texting on your phone and you type in to condense, the goal of condensing is to bring 3 logarithms down to 1 logarithm, right? So what our whole goal and purpose is to get these 3 logarithms reduced down to 1 logarithm. So what I want to do is a couple things we need to remember. Order of operations still carry into pre-calculus. So the first thing I'm going to do, though, is I'm going to get rid of these numbers in front, and I'm going to put them as exponents. So I'm going to rewrite them back as exponents. So I don't need to, I'll just write log base 10 of x minus log base 10 of y squared plus log base 10 of z to the 3rd power. Because remember the property of whenever you have an exponent, you can bring it in front to multiply it? Well, I'm just going to take those back, so now there's exponents. Then, when you guys were doing PEMDAS, if you guys remember, PEMDAS was always do what's inside the parentheses first, then do your exponents, which we did, exponents, right? I just did the exponents. Then it said multiply and divide. And there's a little thing that we sometimes forget. It's always multiplication, division from left to right. You have to make sure you follow that because there is a big difference on how you divide. 2 divided by 4 is different than 4 divided by 2, right? So you have to make sure you work left to right. So I'm going to go from left to right. Well, I can rewrite a subtraction problem as a division problem. Since these all have the same bases, we can do this. So since this division, I can rewrite this as log base 10 of x divided by y squared plus log base 10 of z cubed. Now I can rewrite my addition problem as a multiplication. So this has become log base 10 of x times z cubed over y squared. Right? Good. All right, so this is one of my favorite problems that I like to go through because it just tackles a lot of the properties that you need to go through and just kind of remember. So first thing, we know that we can take our product rule. If we have a number in front, we can rewrite it as our exponent. So I'm going to take all of these terms and rewrite this as ln of x to the 3rd power minus ln of 5z raised to the 4th minus ln of y to the 1/4 power. Now remember, when we have a rational exponent, we can rewrite that as the root. So therefore, that's going to be the 4th root of y. Okay, So now when we're doing a problem like this, we can just work from left to right like order of operations and simplify. So here I have the difference of two logarithms, which I can rewrite as the quotient in one single logarithm. So I have ln of x cubed divided by, now I can simplify 5 to the 4th power, and I believe 625, 5/3 is 125, so that'd be 625. Let me just make sure that I'm not saying, yeah, 625. All right, just wanted to make sure. So therefore I can simplify that to 625 z to the 4th, and then I need to subtract that again by the 4th root of y. Now when we look at this, ladies and gentlemen, if you look at, you're going to subtract this again, well, that's exactly what you need. You need to divide now this again. So therefore now this is ln of x cubed divided by 625 z to the 4th divided by the 4th root of y. You might be thinking, oh man, like, whoa, how am I going to go ahead now and simplify all this stuff? Well, remember, when we have this is another fraction. What we have is, now we have a rational expressions. We have a fraction in our numerator and a fraction in our denominator. So what I can do is just multiply by the reciprocal. Okay? So if I multiply the reciprocal in the denominator, I can multiply by the reciprocal in the numerator. Therefore, this is just going to multiply out to 1. So my final answer is going to be ln of x cubed divided by 625 z to the 4th times the 4th root of y.
Marcus Noel, please
Thanks.
come to the main office. Marcus Noel.
Welcome. All right. Whoa, so now we have some brackets and number multiply. Where am I looking at this? Okay, so before I can take this 2 up to the front, I need to have it as one single logarithm, right? That rule only works when I have 2 times a logarithm. So what I need to do in here is I need to condense this as far as I can, and then I'll bring the 2 up front. So the first thing I can do is I can bring that x cubed up there. So I have 2 times log base x cubed plus log times x minus 1. Now I can multiply these. Since I have the sum, I can rewrite it as the product. So therefore, it's going to be 2 times log of x cubed times x minus 1. Well, ladies and gentlemen, we can simplify that by applying distributive property. So I have 2 times the log of x to the 4th minus x cubed. Then I can now take this up. Now that I have one single logarithm, so my final answer is log times x to the 4th minus x cubed squared. So there you go, ladies and gentlemen. That is how you condense a logarithm into one single quantity. Thanks. Welcome. All right, so what I have here is 1/2 times 3 log base 2 of x minus 2 log base 2 of z. Now, before I can take this 1/2 and apply it up here, I need to simplify this down to one single logarithm. So you can see that I first have my power rule, that I can take my product of my number and rewrite it as the product. So that's the first thing we're going to do. So I'll have this as 1/2 times, I need to rewrite the 3 up, so it's log base 2 of x cubed minus log base 2 of z squared. Okay? So now I see that I have the difference of 2 logarithms with the same base, so I'm going to rewrite that as the quotient. So it's 1/2 times log base 2 of x cubed divided by z squared. Okay? Now what I can do is what I can do is to take my 1/2 and rewrite it as my power up to the top. So therefore I have log base 2 of x cubed times, x cubed over z squared raised to the 1/2 power. Now remember, when dealing with another property of exponents, if I have
Miss Rosa, can you report to the gym? Miss Rosa, report to the gym.
If I have x over y raised to the a, that's equal to x to the a over y to the a. All right, and actually even make that more sense. If I have x to the m over y to the m raised to the a power, that equals x to the m times a over y to the m times a. All right, so when we're looking at a problem like this, what we're going to do is I need to multiply this times both of these. So therefore, I have log base 2 of x to the 3/2 over z. Then I can rewrite this. Let's get a little bit more room. Now I want to rewrite this as my root. So therefore, the 3/2 root is going to be log base 2 of the square root of x cubed divided by z. So there you go, ladies and gentlemen. That is how you condense a logarithmic expression with parentheses into one single logarithm. Thanks. A little bit quicker, but the main important thing, guys, always what I like to do is I always like to do one step at a time. And the first one I do is inside the parentheses. Inside the parentheses, you can see I can apply the power rule. So that's the first thing I'm going to do. And when you guys are getting used to this, OK, so all I did was take the 2 in front and put it up top. Now I see that I have the addition of 2 logarithms, which I can rewrite as the product of one logarithm. So I can write log base 5 minus 4 of log base 5 of t squared r. Doesn't really matter the order. Now I see there's a 4 in front of here, so I'm going to bring that 4 up top. You don't need to bring the negative with it. You can just treat that as a positive and still treat this as the subtraction of 2 logarithms. But I'll rewrite this as log base 5 of y minus log base 5 of t squared r raised to the 4th power. So just remember, when you put that 4, you're putting the 4 raised to your value of your logarithm. Now I can distribute that using the power to product rule. If you guys remember the power to product rule. If you have the product of two numbers raised to the same power or raised to a power, you distribute that across multiplication. Remember, we can distribute across multiplication. We cannot distribute across addition or subtraction. So therefore, I have log base 5 of y minus log base 5 of t to the 8th r to the 4th. Does everybody follow? See that? Then lastly, I see the division. So therefore, I write log base 5 of y over t to the 8th r to the 4th. And there we go. We're done. That's it. Now, we all know that when we're extending this into one single logarithm, you can write that exponent up top. But what I'd like you guys to do when we're applying this, I'd like you to try to, let's figure out in the inside first. All right? So right now we have multiplication. Let's just work from left to right. We have multiplication. Multiplication we can rewrite, Miranda, as if I have addition, I can rewrite it as the product of one single logarithm, right? So let's do that first. So 1/4 log base 2 of x minus 1 times x plus 1. Right? Haley, what's x minus 1 times x plus 1? And who can I pick on? Brett, what's x minus 1 plus x plus 1? And Nathan, what's x minus 1 times x plus 1? And Lucas, what's x minus 1 times x plus 1?
X squared. Minus 1.
X squared minus 1. Yes, ladies and gentlemen. Guys, you can do the FOIL. You can write out the FOIL. But the reason I was just kind of joking around that is because now at this point in time, we really need to make sure we have our special products, right? Knowing that it's a difference of 2 squares. Multiplying up. So yes, this is just going to become x squared minus 1. So x squared minus 1. Then we have minus the 3. I can throw that up top. Log base 2 of x squared. Then when I have the division, Israel, I can rewrite the subtraction, of 2 logarithms as a single quantity using division. Good. Oh, yes, thank you very much. You're not getting smart with me, are you? Thank you very much. I appreciate it. So we have x 1 to the 4th log base 2 of x squared minus 1 divided by x cubed. Right? Right? Now, ladies and gentlemen, what does it tell you when you have a logarithm be multiplied number? You can rewrite that as the exponent. So therefore, now we write this as log base 2 of x squared minus 1 divided by x cubed raised to the 1/4. Now, going back to my familiar rule, raising to the 1/4 power is the same thing, Connor, as raising something to the 1/4 power is the same thing as fourth root. Very good. So my final answer is log base 2 of the fourth root of x squared minus 1 divided by x cubed. Ta-da! Got it? All right, this is going to be a fun one. So I have 1/3 times 2 ln of x plus 3 plus ln of x minus ln of x squared minus 1. Whoosh. OK, so on simplifying a problem like this, again, what I can do is before I raise this 1/3 raised to the power, I need to make sure I can combine these. So the first thing I'm going to do is going to use my product or my power rule. So therefore, I have ln of x plus 3 squared plus ln of x minus ln of x squared minus 1. The next thing is now I'm just going to work from left to right inside my parentheses. So you can see here I have the product. So I can rewrite the sum. So therefore, I can rewrite that as the product of one single logarithm. So it'll be ln of x plus 3 squared times x minus ln of x squared minus 1. All right, now the next thing is now I have the difference of two logarithms. I can now rewrite that as the quotient of one single logarithm. So I have 1/3. I'm going to rewrite the x in front. So it'd be ln of x times x plus 3 squared divided by x squared minus 1. All right, now you look at this and you try to see, is there anything that you would be able to factor out as far as the x's? And there's nothing that I'm aware of. All right. So now I go ahead and take a look, and I have my 1/3. Now remember, now I can rewrite this up top. But remember, 1/3 as a rational exponent is the same thing as the third root. So therefore, my final answer is ln of the cube root of x times x plus 3 squared divided by x squared minus 1. So there you go, ladies and gentlemen. That is how you condense a logarithmic expression into one single logarithm. Thanks. All right, so this logarithm is almost like pushing me all the way to the end. It's getting so big. But I have 1/2 log base 4 of x plus 1 plus 2 log base 4 of x minus 1. That's all in the brackets. Plus 6 log base 4 of x. So remember, when we're applying order of operations, always do inside our parentheses first. So I need to simplify this. You could see I have the sum of two logarithms, which I can rewrite as the product of one single logarithm. So I have 1/2 a log base 4 of x plus 1 times x minus 1 plus 6 log base 4 of x. Now, since this is written as a single logarithm, I can rewrite this now as my 1/2 power can now go up as my exponent. And then I can rewrite my rational exponent as the root. Now, x plus 1 times x minus 1, that's a difference of two squares. Hopefully factoring go through. Then you guys know that we can simplify this now into log base 4 of x minus, or x squared minus 1 raised to the 1/2 power plus, now I'm going to take the 6 and bring it up top, plus log base 4 of x raised to the 6th. Now again, remember, you can see here, now I have two logarithms, and I'm dealing with the sum of the two logarithms, so I can rewrite that as the product. But before I do that, I'm going to rewrite that as 1/2. So that'd be log base 4 of the square root of x squared minus 1, which you cannot simplify, times x to the 6th, which is outside of the square root. So there you go, ladies and gentlemen. That is how you condense a logarithmic expression into one single expression. Thanks.